Hey guys, Ms. Marfleck here. We're going to go over how to evaluate logs. Hopefully you took a look at the slides from our last assignment and got just like a quick idea of what it's about. But we're going to go over it together. Now these notes are, not in a packet anywhere. They should be done in your notebook. All right, so the first thing, we're going to keep the problem in black and our work here is going to be in blue. We're going to convert to exponential form. So we're asking 7 to what power is equal to 7? And that power is 1. So when we go ahead and evaluate log base 7 of 7, your answer is just 1. We're not going to be including the x equals 1 or y equals 1, but here we're just evaluating log base 7 of 7 is equal to 1. I don't know what happened to my highlighter, but that's okay. Here we are taking a look at the second one, log base 5 of 25. We're going to write this in exponential form, so we're asking ourselves 5 to what power is equal to 25? And you should know that off the top of your head, that power is 2, because 5 squared is equal to 25. So our answer here is just going to be 2. Taking a look at this next one here, number 3, we're going to evaluate log base 2 of 32. Converting to exponential form is always our first step. We're asking ourselves 2 to what power is 32. Go ahead, take a minute and kind of count on your hands. But when you do count, you're going to figure out that power is 5. So then our final answer here is 5. Log base 2 of 32 is equal to 5. Now I'm using x here for these past 3 examples, and I'll just keep it going with x in the future, but you could really use any variable you want. You're just writing in exponential form and you're solving for that variable. All right, please stick around and keep watching the video because they do get a little bit harder from here. So now we're seeing this is our common log, which you should have seen from the slides. When you don't see it, it's assumed it's base 10. So we're asking 10 to what power is 1,000, and you can go ahead and just count those zeros, and you have 3 zeros there, and your answer will be 3. Now on the common log slides, you should have seen, some negatives, powers and positive powers, and I asked you to kind of analyze that pattern there, and it makes it a lot quicker than going ahead and using the calculator. All right, here's an interesting one for us. We're going to read 5 to what power is 5 to the 7th, and we're going to go ahead and just use that equality property of exponentials, and we can get rid of those bases, and that means that x is equal to 7. So 5 to the 7th is equal to 5 to the 7th, and there's our final answer there, 7. And if you want to check that, you can write it in exponential form, and you'll see that both sides are equal. We're going to try to squeeze in number 6 down here. We're going for it. This is our common log of 1. So that means 10 to what power is 1, and any number to the 0 power is equal to 1. So log of 1 is just 0. If I'm going too quick, that's okay. Pause the video, kind of go back and review those, first 6 problems before we keep it going here, because we use harder and harder exponential properties, such as in this example. We're going to convert to exponential form, which we should be super comfortable with, and this is 4 to what power is 2. Well, I need to use the equality property of exponents, so I need to get the same base on both sides. And I'm going to take out that 4, and I'm going to replace it with 2 squared. And then now on the other side, on the right side of the equation, even though you don't see it, that's 2 to the 1st. And then I can kind of just get rid of those bases using the equality property, and here we are, we have 2x equals 1 and x equals 1/2. So once again, we write in exponential form, then our goal is to get the same base on both sides so that we can use the equality property to solve for x. Now, just kind of like a side note here, we did already do a lesson on exponentials a little while back, maybe a month ago, and we talked about power over root. So 4 to the 1/2 is equal to 2. And I'll show us here with our variable power over root, and then also that's going to be 4 to the 1/2 is the same as the square root of 4, which is equal to 2. So that's just kind of a quick review for us. All right, we're going to see more examples like that. Don't you worry. And here we are, number 8. All right, we're still sticking with the evaluating, and now we're doing log base 5 of 1 over 25. All right, same concept here as the one before. We're going to use our exponential form, and we have 5 to the x power is equal to 1 over 25. And then now our goal is to rewrite that 25 with the same base. We know 25 is 5 squared. All right, and then we're going to use even one more property of exponents, our inverse property, and we're going to bring that 5 up into the numerator, and now the sign of the exponent changes. Then we have the same base on both sides. We can use the equality property, and we're left here with x is just equal to -2. So log base 5 of 1 over 25 is -2. And you're going to see all these problems kind of follow those same steps. And those are our main powers that we're using. Our goal is to get the same base on both sides when we're working with an exponential equation. All right, number 9, we're going to evaluate log base 10 of 0.01. Now you should have seen on the slides that when we go and we have negative powers, we're moving that decimal place to the left. So we have 2 decimals places, so that's going to be our -2. So what we're really doing is we're starting there at 1, and we're moving to the left decimal places. All right, going forward and taking a look at our next example, number 10. We're going to evaluate log base 16 of 2. All right, first step, go to that exponential form. 16 to the x power is equal to 2. And then now get that same base. Well, 2 to the 4th is 16, so I'm going to take out that 16, replace it with 2 to the 4th, but I still have that power of x there. All right, and then now the 4 and the x multiply, and now I have 2 to the 4x equals 2 to the 1st. Equality property, get rid of those bases, and then go ahead and solve for x there. And then we get here that log base 16 of 2 is equal to 1/4. All right, exponential form, equality property, and then solve for x. I think we're almost done here. We've got a few more examples. Number 11. We're going to evaluate log base 2 of 1 over 16. We're going to go ahead and write that in our exponential form. Well, that's 2 to the x is equal to 1 over 16. And then now I need to write that 16 with the same base. Well, I know I don't want what's above it to confuse us, so I just crossed that out real quick. Well, I know that 16 is 2 to the 4th power, so I'm going to take it out and replace it with 2 to the 4th. And then now we're going to use that inverse property of exponents to bring that 2 to the 4th up in the numerator and make that power negative. And then now I have the same base on both sides. Once you have that same base, you can get rid of them, use that equality property, and then you have x is equal to -4 here. So we have log base 2 of 1 over 16 is equal to -4. All right, and then I think I got one more for us. One more we'll do. And then we'll call it a day. Well, I will call it a day, but you guys will still have to do some more practice problems. But here we are, number 12. All right, we're taking a look at evaluating log base, that's a 6. It's a really ugly 6, but it's a 6, of 216. Now, if you don't know this off the top of your head, that's okay. You can play around with a calculator. You'll have a calculator on assessments. You should be able to figure out that that is equal to 3, right? Because, 6 squared is 36, and then 36 times another 6 is 216. All right, go ahead. Feel free to look up some more evaluating videos on YouTube and Khan Academy if you're stuck, or pause and kind of go back to those harder examples and then get started on your homework. Email me if you have any questions. Bye, guys.